Thank you all for coming out. This is very exciting to see all of you here. My name is Jonathan Buzan of the Water Club, and this should be a very exciting evening for us all to learn a little bit more about the future of Fairfield stormwater. I would like to thank everybody's for helping us out with that delicious Mountain Valley spring water back there. Help yourselves, stay hydrated. It's very good, lots of minerals. And also, I'd like to thank the Fairfield Public Library for helping us use this space. I'd like to thank Eco-Fairfield for helping us with outreach and publicizing. And most of all, I'd like to thank our speakers for coming out and sharing their time with us to let us know everything that's going on. So first, we're going to start off with Darren Hamilton of the Fairfield City Council. He's going to be talking about the history of Fairfield's stormwater and the state revolving funds that are going to be coming through that might be available for us. And then after that, we have Melanie Carlson, engineer with French Reneker and Associates. She's going to be talking about the phases of the new treatment plant project to convey the water to the wastewater treatment plant facility, which will segue into Shawn Worley's talk. He's the superintendent of Fairfield's wastewater treatment plant. He's going to be telling us about the project to expand the facility to help with the overflow issues that we're having. And then we have James Martin from the Iowa Department of Land Stewardship. He's going to be telling us about the steps of surveying the watershed and the types of things we look at when we start to analyze our watershed to figure out where our problems are at. And then we have Tom Barrent. He's the president of Green Water Infrastructure. He's going to be talking about watershed management and some of the new green infrastructure and best management practices that are happening, and that maybe we might have an opportunity to implement here in Fairfield. So with the Water Club, we helped put this together. We are a student group at Maharshi University of Management, and we are interested in seeing new water management practices, particularly with an emphasis on the watershed, not just point source use and things like that, but kind of looking at a bigger picture. So we've been doing a lot of work recently, doing assessments for the city for the Crow Creek watershed, and also looking at some of the urban infrastructure in Fairfield. We spent our spring breaks going through town, doing all those assessments, and it was a lot of fun. So we're really excited. We've got a lot of big ambitions in the future, and we're just trying to get the ball rolling with outreach, get people in town more aware of what's going on with our water. So without further ado, I'd like to open up the floor for Darren Hamilton.
Again, I'm Darren Hamilton. I'm the city councilman for the 5th Ward here in Fairfield, which is the southwest corner of town and across the southern part of the city. And I've been on the council for approximately 12 years now. It's been quite a while. I've been in various different subcommittee chairmanships, but in approximately 2003, I became the chairman of the Utilities Committee, which oversees the water and sewer department here in the city of Fairfield. Part of that was I had taken over for a previous person, Tom Stanley. I think some of you may know or remember Tom. And he was pretty involved with the water side of our operations and wasn't really much with the sewer portion of it. But after I had taken the chairmanship, we kind of had to change focus a little bit from where we were at. We received notice from the Iowa Attorney General's office that we had an extreme problem with our sanitary sewer overflows. This was something that I eventually discovered had been going on since the mid-1980s. Sanitary sewer overflows are when your system receives too much water from external sources other than what should be in your sanitary sewer, and it causes backups, it causes manholes to pop their lids off. I've witnessed manholes with a cover that weighs probably close to 100 pounds, and the cover's flopping around like it didn't weigh anything. The volume of water that was coming out was so great. From this administrative order that we received from the Attorney General here in the state of Iowa, we're currently in about the 7th year of that order, and the order was for a 10-year time period. With negotiations with the Iowa Department of Natural Resources and with improvements that were initiated in the beginning, we were able to extend the time period that we had to make these repairs beyond the 10-year mark. We had initiated a plan here about 6 years ago, and we were trying to attack where water was getting into our system in the easiest ways that we could. Downspouts on your homes that went into the ground, nobody knew where the water went. We did some discovery on approximately 600 properties, found downspouts that went down into the ground and no one knew where they went. After some testing, I think only about a quarter of those homes had problems with the water going into the sanitary sewer system, and so those were cut off at the ground, and the water is now out on the surface. In thinking of terms of that, where you have redirected water that once was going to a location that it should not be going to, you have to divert it somewhere else. So you have to think in terms of, all right, I've got so much water running off of my roof that creates quite a pond in my yard for a while. What happens to it from there? We worked in conjunction with a man by the name of Wayne Peterson. I think he was here this last Monday night and spoke. And Wayne has some very strong ideas on how to manage that type of water once it comes down, either using rain gardens, which are a popular method, or barrels to repurpose the water after it's come down, or trying to direct it so that it will work and water different areas of your lawn that you would like to have watered during times of the year. One of the test projects that we did with Wayne right off the bat was a rain garden down at the middle school. I'm not sure if I'm using the name of that properly or not, but what we did is we built 2 retention areas, and we've planted them with various types of water grasses and water native type plants, and we capture the water that's running off of the middle school parking lot to the west into these gardens so that it can be slowed down, filtered, and then put into the drainage swale that is just a little bit farther to the west. We've also done a project similar to that in a couple of different locations here in town. We use those because of not only are they really pretty to look at afterwards, they have a very specific function in order to filter the water that comes off of a parking lot or a building, because there's a lot of errant material in that. You've got all the oils and greases that come out of your automobiles that get into that water, and it needs to be cleaned before it's put into a stream that can filter down through to Big Cedar Creek. We have done a couple of permeable parking areas here in town, which is a pavement that allows the water to flow down through it into a smaller retention area, and then it's filtered again before it's drained into the stormwater system. Stormwater intakes along your streets in town is where that water normally goes to. The parking lot by the Sondheim Theater, the city municipal parking lot, has a brick paver area that's in the parking lot, and when you go by there you can see it. There's nice concrete around it, and then we've got this area of brick pavers, and the water drains into that area, goes down through a sand and rock type bed, and then it's filtered off and then goes into the stormwater system. The other is out by Chapel Studio, and it's a parking lot that filters the water that comes off of it and then goes into the pond that's adjacent to it. It's a vastly different type of paving material. It's more of a granular type surfacing out there than it is a concrete and brick. Those types of projects are what we would like to focus on in the future with some funding that's going to be generated through our sanitary sewer improvements that we're going to be doing. About 2 years ago, I think the state of Iowa implemented what they call their Clean Water State Revolving Fund. And what it does is, and I'm sure we'll get a better explanation later, but what it does is it allows the city to borrow money at a reduced interest rate, and the difference between the interest rate not using clean water funds and what you would with the clean water funds is to be diverted back to projects for stormwater cleaning, retention, doing waterways so that the influx of more water coming into it is not damaging what is out there now, trying to retain where we're at or improve areas along the different creeks that we have here. Crow Creek on the east side of town, Indian Creek on the west side of town, and then all the way down to Big Cedar Creek. The drainage area on the east side of Fairfield encompasses about 11,000 acres, somewhere in there, 11 to 12,000 acres. And that's a huge amount of area. And all the water that comes down through that then funnels into Crow Creek and then continues on down to Big Cedar. So the water group here at MUM has graciously helped the city of Fairfield by doing a survey of the area around the city of Fairfield to try to figure out where we could best focus this money that we'll be able to generate. It's been a real uphill battle. I mean, for many years, in the mid-1980s, the city of Fairfield still operated with what they called a water board, which was independent people that were appointed to a board commission by the mayor. And those people then would oversee both our water and sewer department. Needless to say, citizens don't want to raise their own rates when they get in positions like that. And so maintenance kind of fell by the wayside, and only projects that were felt to be absolutely necessary were done. I believe we were fined the very first time for sanitary sewer overflow by the state was in the mid-80s, about 1985, I think it was. We had a $3,000 fine levied against us. And at that time, no one had really stepped up and said, okay, we recognize that we have this problem, we need to take care of it, let's do something about it. It was more, they didn't want to push it too hard on us, we didn't want to push too hard back on them, so the status quo was maintained. We've had four different plant operators in the time that I've been the chairman of the committee, and each subsequent plant operator that we've had has done a better and more conscientious job than their predecessor. We've expanded our programs now to the degree that we have our STEP program in place. We're also working that on the water side, a STEP program with it. We have the third reading of our utility rate increase for water coming up at our next council meeting. But we have plans to do that with the sewer, and we've done that with the sewer to this point. We've had some great help from our engineer here in Fairfield, Reneker, through all of this process. I've consulted with them a lot of times on trying to figure out what would be the best plan of attack in order to be able to do something, and then my job has been mainly focused on trying to figure out where and how we can generate the revenues in order to do it. It's not easy. It's something that I felt really needed to be taken up by someone, and I've been pretty pleased with the results that I've seen. And I think, 50 years from now, people will look back and say, oh, this really was kind of a tough time to try to do something like that, but it will be remembered as the largest public works project undertaken by the city of Fairfield since its inception, since the sanitary sewer was initially put in here in the city. In July, thank you. In July, the city of Fairfield is going to celebrate 175 years. 175 years ago, you had a collection of 4 or 5 homes, created a town, had an outhouse behind you. You didn't think about this kind of stuff. 100 years ago, we were putting in sanitary sewer and water to everybody's homes here in the city. And at that time, with the buildings in the downtown area, it was easier to divert the water into the sanitary sewer system and let it all go with where all the water was going to at that particular time. Over the years, it's been proven that that was not the wisest decision to be made, but at the time it was what was accepted as the standard practice. And in the eastern side of our city, the eastern trunk lines, one of them out there is about 100 years old. The other one was built in the later 1930s, 40s, and 60s. But our plant hasn't had too much of a change in the last, we did some major improvements in the 60s and then again in the 80s. Recently, we've done our biggest and best improvements. So I think I'm going to pass it on now to Melanie.
Thank you. My name is Melanie Carlson. I'm an engineer with French Reneker. Our company has been working with the city of Fairfield for almost over 50 years. And as Darren alluded to, about that long we've been working on getting the sewer project going. Not quite. I'm going to give you a few terminology, explain some terms that you may have seen in the paper to help you understand the utilities with the city of Fairfield. There should be 2 sets of gravity pipe in the city. There's the stormwater pipes and there's the sanitary sewer pipes. Sanitary sewer pipes should carry things, your bathroom waste, your shower, your washing machine, and your floor drains. At a minimum, the black water type stuff needs to go into the sanitary sewer. Your storm sewer pipes, in an ideal world, carry your surface drainage, your roof drains, and can even include some of your gray water items. Now, in older cities, Ottumwa, for example, is going through this. They didn't build a storm sewer pipe when the city was built. They just built one pipe, and that's what Darren was talking about in the downtown area, in the oldest areas of Fairfield. They built one pipe and they put all the water in it. And so those areas and those cities have to go through a lot of trouble, even more trouble than the city of Fairfield, to separate out the gray water and the storm water. And in Fairfield's case, we've got some areas with just one pipe. And I hate using quotes, but it's more complicated than what I can do in 10 minutes. But then in Fairfield's case, there are areas that have 2 pipes, but sometimes those 2 pipes are connected. They've got the storm sewer and they've got the sanitary sewer, but somebody thought that this area drain that catches the street water, it was just easier to put it into the sanitary sewer rather than keep it in the storm sewer. Or maybe it was someone's sump pump or roof drain. And the city has worked very hard over the last 10 years getting out those sources, those easier sources. There's some of them, for example, the storm sewer drains along most of Highway 1. And these are the curb inlets that looks like maybe a small dog might be able to get in there. I mean, they're kind of a big opening, so they take a lot of water. Those actually, McClure Engineering Company, another engineering company that has been assisting the city of Fairfield, they did smoke testing. You probably saw this in the paper, where they smoke the sanitary sewer and see where it comes up out of the storm sewer. And that shows where there's the cross connection between the two pipes. Well, Highway 1 intakes are an example of a place where there were a lot of connections. And those they're not an impossible fix. They're not an easy fix. And even if you did do them, you're still going to have overflows. So the next term is the SSOs, the overflows. That's the basic terminologies we see. The SSO stands for sanitary sewer overflow. And it's a point location where the sanitary sewer water that has all of this extra cross connection water, where it's coming out of the sanitary sewer. And in your handouts, your larger handouts are up here. There's some pink, reddish dots. There's about 21, 22 that show up on the map. And these, over the last 10 years, these are the more common places that we've seen, or that the sewer department has seen overflows. Some of them are isolated events related to a plug or a malfunction in a lift station, but some of them are more common. The next term I want to show you is interceptor sewer, and the different names for the sanitary sewer. So I'm talking the sanitary pipes. And the major improvements that the city's taking on over the next couple of years are related to the sanitary sewer. But what it helps do is it moves that water along instead of getting bottlenecks, so that it's not coming out of those isolated points. So the interceptor sewers are the trunks, the main collection areas where all the little fingers come into. And if I knew, I think of it a lot like your lung system, but I don't know all the different terms for the lungs, so I'm not gonna. So you got your main part, and all these little pieces come into it. So what the city is looking at over the next couple of years is a 4-step process to replace these main trunks and make them larger, break up the bottlenecks. The first step, and we are calling them steps. Step 1 takes you from Lamson Woods to the treatment plant. Step 2 takes you from the university down to Lamson Woods. And without having the aerial photo behind it, it's hard to see where it is relative to Crow Creek, but really the lowest point in town is Crow Creek and Indian Creek. So that's a logical place to build a gravity sewer. So Crow Creek runs right in the middle of the 2 existing pipes that are going to get replaced. And so a lot of these red dots are right adjacent to Crow Creek because that's where the bottlenecks are happening. So we've got step 1, step 2, then step 3 comes across Highway 34, or it crosses Highway 1, but it's parallel to the 34 bypass. And step 4 is replacing the stuff along Indian Creek, relieving the congestion where all of the fingers come in here on the west side of town. So this is the sanitary work that the city is working on to help alleviate the sanitary sewer overflows and helping with the Crow Creek in a sense of eliminating the sanitary for it. Not necessarily doing anything directly to Crow Creek, but getting all of that E. coli out of the Crow Creek is going to be a huge benefit. So I'm going to turn it over to Shawn to talk about what happens when all of this gets down to the treatment plant.
Good evening. I'm Shawn Worley. I'm the Wastewater Superintendent. I've been with the city for going on 9 years now. Started out as a fabricator and soon realized that really wasn't my calling. Found I wanted to start protecting public health with wastewater treatment and the properties that it takes to do that correctly. So I went through all my licensing, got my grade 3 license to be able to run the treatment plant, and took over a year and a half ago. Along the way, we've seen a lot of changes happen so far, a lot for the better. Our treatment plant was built, the first major rehab was 1966. Most of the equipment that we have now was actually put in at that time. So you can tell from that time, some of the equipment that we have, like right here, which is a manual bar screen. There's 3 of these, and that actually catches all of the inorganic material that actually comes through the plant. The problem with this is it has to be scraped manually once a day. It plugs very fast, and anything that gets by that eventually goes through our plant, and now we're trying to treat inorganic material, which is impossible. So this is just some of the instances of where the treatment plant is at now. The primary clarifiers, they're 2 large tanks. That's where the organic material that's heavy will actually settle out of the wastewater stream. We feed our digesters with that material. That's a very important part of our treatment system at this time. It's completely failing. The concrete walls are actually coming in on it. We spend a lot of time and money every year rebuilding that system. Overall, this can go on and on. The lists of problems with the plant, it was updated in 1984. We did another update with the plant. A lot of new things were added. We literally almost doubled the treatment plant size at that time. Soon after that, within the next 5 to 10 years, we found that that's not big enough either with the problems that we have out in the sewer system. Some of the items that Melanie was talking about, the overflows that we have in town, all of our major overflow sites that we know of that we monitor is pictured here. This is one of them, for instance. We have computers that are actually in the sewer system itself. They're data loggers. They actually log all the rainfall or all the water that comes through that sewer system at any given point. After every rain event, we go out, download all the data, and that's any reporting that we do to the DNR now, we can actually report those numbers to them, and we're absolutely precise on that. That has really given us a better idea of where we need to go with this in our collection systems and how to plan out the progress of the collection system that French Reneker has put together is with data logging and know where the flows are coming from. So the updates to the plant that we're looking at now, I did have some flyers back there too. The plant right now, at the point that it's in, the maximum wet weather capacity that we have is right at 3 million gallons. 5.7 if the plant is pushed completely to capacity. On the flow data study that we had found, when we did the flow data and with the new collection systems, on a 10-year rain event or above, we could expect up to 40 million gallons to come through the plant. Per day, million gallons per day. At that rate, the plant is still not anywhere close to being big enough. The answer to this was we're still conveying the water to the plant because we want to stop our overflows. That's the first thing that we have to do, is stop our overflows out into the system. The first step to that was actually to build a retention pond. That's one of the things that we need to do. We're looking at a 20 million gallon retention pond. What that does is the excess water that comes in on a storm event, if we can't treat that much at the plant at any given time, we can put it to the storage pond to store until our flow comes down. Once the flow comes down to an acceptable level and we have some cushion, we can start bringing that water back slowly into the plant. With that addition on that 20 million gallon, along with our other 2 storage ponds we have currently that hold 10 million gallon, that gives you that cushion that we need. The new treatment plant with the proposed capacity, peak hourly wet weather would be 42.1 million gallons. General treatment throughout any given day, which would be normal treatment, can go up to 9 million gallons. The plant this time is actually being designed not only for the extra water that we're going to be having to come in, but it's also being designed and looking to the future of Fairfield. We don't want to build it too small now. This is the time that we need to build it. So we do have some room for expansion. As Fairfield does expand, our treatment plant can expand with that. It'll also help us meet some of the new limits that we're going to be facing. not only with potassium limits and stuff like this that's coming down the pipe, but we're also going to be able to start being able to meet more of our ammonia limits. Ammonia limits are starting to come down, and this gives us that ability to be able to do that. So some of the new projects at the plant, the whole headworks assembly, right now it's based off of 2 pumps that we have a high flow and a low flow that runs the water through the plant. All of that is holding its own for now, but it's met its lifespan. So there'll be a whole new headworks building that'll direct the flow through the plant, as also it'll have extra pumps that'll take water up to our holding ponds. Bar screens, the mechanical bar screens are finally going to go away. We'll have automated bar screens, which have been around for 30 years or so or more. They're a very good operation. It cleans 24 hours a day. It's going to help a lot with our inorganics to be able to separate it out. Also, it washes. It'll go through a wash cycle. So it actually washes any organic material that's on the inorganics. So it reduces the amount that we have going to a landfill. It can reduce it up to 30 to 40% by washing the organics out of it. We can treat the organics. That's what we want. Along with this, in 2010, we just finished up a sludge storage tank. It's a 1 million gallon. What that did is give us the opportunity to be able to store sludge throughout the year. Before, we were having to field apply at multiple times in the year. We really decided that that's not the best operation for us to do. We don't like to apply on frozen ground. That took our winter out, basically. We only had very short windows to be able to apply. Crops would go into the ground, so it really limited us. With this, we can store all year. As soon as the crops come out of the ground, now we can field apply all in one shot. With that, we don't quite have the capacity that we need now with the single tank, so we're adding another. We'll have 2 million gallons of storage capacity, which leads into now our storage tanks will be actual aerobic digesters. We're stepping away from our anaerobic digesting system that we have now. We're seeing some failures with it. The anaerobic system actually costs us energy to have to heat the digesters. The digesters have to stay at a consistent temperature of somewhere around 95 degrees in the mesophilic state. With doing that this winter, we were running out of biogas. We're not producing enough biogas to be able to heat it, so we were heating our digesters with LP all winter long mostly. It got very expensive if anybody paid attention to what bottle gas was bringing this winter. We were up to some weeks we were spending $5,000 a week on bottle gas. So this gives us a whole nother opportunity with this. Our sludge, we can actually hope from bringing it a class 2 sludge down to a class 1 sludge, which gives us a lot better availability to be able to spread on fields. It's a lot safer for the environment. By doing a class 1 sludge and bringing that down, we've actually destroyed most of the microorganisms in that sludge at that point. Class 1 sludge is almost the best you can get. There is one class better. For a public treatment system like this, it's really, really hard to get to that next one, but that's still availability to us. With that, we're actually adding another ditch on, which are an oxidation ditch that treats the wastewater. That'll bring us up to 3. That's what really brings us up to our extra capacity of 9 million gallons, is adding this extra ditch. The highlight, and which I'm really proud of us being able to do this, right now we use a polishing pond. It actually polishes the water. It takes any of the extra ammonia out of the water before we discharge into the creek. Right now we're meeting the standards that we need to meet with that. Over the last 2 years, we've had some of the best effluent water than we ever had in the city of Fairfield coming from a treatment plant. It's worked very, very well. Our treatment process is working good, but we keep very close monitor on it. With the new project, we are going to be able to go to UV disinfection. That's a very good win for the city and for everybody. UV disinfection is a marvelous system to be able to use to disinfect our water before we put it into our receiving stream. The new UV disinfection systems are very energy efficient, much better than they were 5 years ago. This comes at a perfect time for us to be able to do this now rather than if we would have done it a few years ago. The energy savings now with the UV compared to what it was is almost 50% savings of what it used to be. And that's all designed on light placement on how they're doing that now. With the UV disinfection, they have rows of lights and they run the water through those lights. The actual light itself is what will kill off any bacteria that comes by the lights. It kind of sums up what we're looking at with our treatment plant, where we're going with it. We're hoping that this will bring us into the new age of where we should be. Our treatment practices have been very good up to this point. I can see us very improving on this throughout the future and be able to handle all of Fairfield's needs.
Thanks for having me. Again, my name's James Martin with the Iowa Department of, and Jonathan, you said land stewardship, so that's kind of, no, that's good actually. We're the Department of Agriculture and Land Stewardship, but we do like to be land stewardship and agriculture as well. And what that does is it helps us bring together the agriculture and urban, together. And because all our watersheds, more and more what we're dealing with is trying to treat all the resource concerns. And so we know there's urban and there's agriculture out there in Crow Creek Watershed, for instance. And in order to achieve clean water, healthy water, we need to be looking at both. I think it was mentioned, Darren, that 50% of Fairfield drains into Crow Creek. Crow Creek is about Fairfield is about 20% of the whole Crow Creek, and so there's going to be a big impact that Fairfield would have in addition to the agriculture. And so what I do with the Department of Agriculture and Land Stewardship is provide technical resources to watershed groups, be they cities, counties, environmental groups like the one at MUM, or other volunteer groups. So I work in southeast Iowa. This is part of my area, and I basically provide planning assistance, and what we do is follow a 9-step planning process, and so that's something I've been helping the group here with. And I tell you, we really would not be here where we're at without the group at MUM. The students have been awesome to work with and have provided a lot of information that's really helped, I think, the city and French Reneker and a lot of stuff. So it's been great, yeah. We totally appreciate that, because if we follow the process and we get good information, then what we're going to end up with in the end is a better project with a better result. And so that's kind of what we're all after, and it does take a lot of different hands putting them together to get at that success. I'll just quickly go over some of the assessment items. I didn't want to go into too many details, but we offer grants through the Department of Agriculture and Land Stewardship to do watershed assessments, and the local soil and water conservation districts are the eligible applicants for that. And so they went after a grant to put together the resources to do the assessment. Meanwhile, the students have been doing some great work, so it's actually freed up some dollars to maybe potentially, improve our assessment process. So it's just been another big win. Like I said, I work with agriculture too, and a lot of our landowners have taken advantage of low interest loans over the years to do conservation work like terraces and ponds and prairie strips. And so that's been available through the state of Iowa for a number of years now. It wasn't just until the last couple of years that the SRF program has allowed low interest loans for water quality on wastewater projects. And so that's something that, again, Darren mentioned earlier, that was something that the city applied for just recently, and hopefully we'll be hearing more about that in the future here. So this project that I've been helping with is trying to put together a plan to say, okay, these are the highest priority needs out there. In addition to the overflows, what other surface water runoff generated resource concerns are out there. Agriculture might be part of it. Some of it might be runoff from urban yards or big parking lots and things like that. And so we try to put together the picture and figure out where some of our priorities should be. And so that involves actually walking the creek, seeing what the creek looks like, taking a handheld computer with a GPS, and taking a number of different statistics. That's what the students had been doing. How high is the bank? How wide are the buffers around the creek? Where is there different problems with bank erosion? And things like that. We're also looking at the actual land use. How much is row crop in the row crop area? How much conservation is out there? Quantifying erosion. So how much sediment is the creek transporting to the Big Cedar? So we can get an idea of sediment load. And then with the urban, we want to try to figure out how much stormwater is moving as well, so we can quantify that. And so we're just really, we've been doing great. We've done a lot, and then there's more to do. And so we'll be working at that process. The Soil and Water Conservation District here in Jefferson County did get that grant, and they'll be working at it over the course of the next year or so to implement and come up with a kind of a final recommendation. Then would allow them to go after additional grant dollars to go after the priorities. And these are grant dollars that are available to watershed groups all over the state. And so a really good plan is really advantageous and puts you in a good position to be awarded those grant funds. And with the SRF dollar potential from the wastewater project, that's going to be all the more leverage that the city and groups can use to get more dollars from other sources rolling in to start kind of plugging in pieces of the puzzle. So that's about all I have for now. I'll wait till later for questions. So I'll turn it over to Tom.
And so how I usually start, some of you have heard this, water, water everywhere, and not a drop to drink. Do you remember that from the rhyme of the ancient mariner? The mariner's on a raft out in the middle of the ocean with his dead albatross around his neck. And all of that salt water's no good. And today, we in America face that same situation. 80% of Iowa's waterways, they'll tell you, are impaired. And impaired is a nice way to say they're polluted. And quite frankly, we can do much better than this. We're at the 50th anniversary of the Clean Water Act this year. And we've done a great job on point source pollution. Love Canal, the Gowanus Canal. We know about those things. But today, in America, the greatest source of pollution for our waterways is stormwater. So with that, my name's Tom Barrett. I'm the owner of a company called Green Water Infrastructure, and what we do is we try to develop water resources for sustainable site solutions. We look at it from a holistic approach. And green infrastructure, if there's anything that you want to remember about it, because green's been overused in my opinion, is it's natural, it's biomimicry. It tries to bring nature back into the fold. And what's really nice to me and exciting to me about green infrastructure is it actually has the opportunity of, instead of trying to minimize our impact, it enhances our environment. And I'll show you that in just a minute. It's clean because it creates more complete filtration. It's lean. Generally speaking, green infrastructure can be less expensive than conventional gray infrastructure. And it's the future. It's what we see going on in other parts of the country and throughout the world. So here is the hydrologic cycle, or what happens when rain falls in our area before we had all the urbanization, all the development, all the agriculture that's going on. What you'll notice is as the rain fell, less than 1% of it ran off of the surface into our local waterways. And the water that runs off of the surface of our land carries with it the pollutants from the surface of our land. You'll notice 40 to 50% of it goes up into the atmosphere. About 10 to 40% goes down and recharges our groundwater. And 20 to 30% goes through what they call the interflow layer. Back when we were native prairie and deciduous hardwood forests, those roots went down 18, 20, 30 feet and it helped to create porosity in the soil. And how many of you have ever been in the forest when it rains? You don't really get that wet at first, do you? Unless it's a complete downpour. Those leaves help to slow the velocity of the rain. The water, when you walk onto the surface of an undisturbed forest, the soil is very, very soft. It's spongy. It's about 30 to 40% compacted, as they would say in engineering. With our development, that's what's gone on here. Even our urban areas, our suburban areas, we will see 92% compaction at our soils. So to give you an idea what compaction means, concrete, asphalt is 100%. It's rock solid. Everything runs off of it. Gravel roads are about 92%. When they base a road, they get 92% compaction. It's almost impermeable. And that's what we've done to most of our lawns, to a lot of our agricultural fields. We're highly compacted. So, to give you some numbers, what are we talking about? A 1-inch rainfall here in the city of Fairfield on about 2,300 acres generates 62.5 million gallons of water. That's 1 inch of rainfall. That's why this is so important. There's a lot of water going on here. Anybody have any idea? Some of the students, how much is 62 million gallons of water? About 6,000 swimming pools, right? Put it in terms I can understand. How much falls in Jefferson County? This number is astonishing. This is not for the whole year. This is one 1-inch rainfall event. 7.6 billion gallons of water. Enough water to sustain over 200,000 people if we had a population using 100 gallons of water per person per day. That's a lot of water. And what we're doing with it right now, and generally speaking, where 1% of it used to go into the streams, 40 to 60% of it now flows into the streams. So we rapidly collect it and we pipe it into our local streams. And you guys and gals that were doing the stream assessment, what did you see when you were looking at the streams? It almost looks like a war zone. As you guys didn't use that with me, but you said you went 2.5 miles along the creek, and these guys and gals are amazing because they were out there in February when it was close to 10 degrees out. 9 below, Dina said, okay, you guys can stay inside, but anything above 9 below, she forced them out. And it's great to have the community working together, because you're going to see in a minute, it's really important for a community to work together to make this happen and make a huge difference. Because what's been going on has been going on, as Darren said, for over 100 years. And the answer to the past with civil engineers has always been the answer to the solution is dilution. We get enough water and it's pretty pure. Don't tell Seattle that. They just dumped 32 million gallons of water because somebody kind of weed in their reservoir. Did you guys see that? Yeah, 32 million gallons of water. This was last week. It's the second time they've done it in 2 years. So anyway, I'm getting off track and only have 10 minutes. So what's going on now? So this surface water is running off, and what it's doing is it's carrying the nitrogen, the phosphorus, and right here in Iowa, atrazine. We are like the atrazine capital of the country, and that's why we're using groundwater right here in Fairfield as opposed to using surface water, because all of this is carried off of the farm fields. Now, this is not to say that the farmers are bad people, but it's to say we've got to recognize the problem, and we have to deal with it. And green infrastructure, in my opinion, is the best way to deal with it. Green infrastructure, in my opinion, is the best way to deal with this. The eurification, as all of our streams collect, converge, all of these pollutants start to increase, go into the Mississippi, in through the Ohio, out to the Gulf, and we have a 60 square mile dead zone because the blue-green algae is toxic. It uses up all the oxygen. And we don't have to be like this. We can do it much, much better. So, where does green infrastructure fit in? It's a tool, and there's a variety of things I'll show you in just a minute what those tools are. But the concept of green infrastructure is we capture the water, the rainfall, as close to the production of the rainfall as possible. On the agricultural field, next to the building, as close as we possibly can without damaging the structure of the building. We slow it down, just like in a natural forested area. We soak it into the land, into the soil, because the old sewage treatment plants used to have 4 feet of sand and worked a little bit like an aquarium. They filtered the water as it went through the sand. We get 4 feet of sand with the right biology, we've got almost drinkable water coming out. This is what we're trying to get to. We apply it to the landscape, which means we have more plants, which are really great, and we create habitats too, although some of the suburban areas don't like the mice and the snakes and stuff that come along. So there's, honest to God, that's part of the problem. Most important thing we can do here, Scott, Tim, what have you been doing for the last 2.5 weeks? Planting lots of trees. They say the value of a tree over its lifetime, one tree is worth $60,000, University of Colorado. Think about what trees do. They filter the air, they create oxygen, they sequester carbon, they create shade, which reduces the urban heat island effect. There's so many benefits to trees, and this is why I say green infrastructure, when properly done, doesn't minimize our surface, doesn't minimize the impact that we have as we try to do with HVAC or buildings. What it actually does is it makes our environment better. We start to restore the natural landscape. So some of the things that you've seen, I'm going to touch on these briefly and then let this go to questions and answers. Rain gardens, this is up in, I think it's up in Portland. Portland, Seattle are doing the best in the country right now. You can see they're pretty nice, but I've actually got pictures of just grassed over rain gardens. It's an inverted landscape, but it's got to be engineered. Porous paving, this is the real hot and sexy topic. They like porous paving. It is the most expensive way to mitigate stormwater. And quite frankly, in my opinion, it's not green, but it's better than concrete. But there's no plants with porous paving. And what happens with the plants actually help to remove some nitrogen, remove some phosphates, and definitely this gets rid of all your heavy metals and petroleum distillates in there. And then we have green roofs, which are all kinds of wild things going on with green roofs, but they have to be taken care of. City of Chicago has 800 green roofs, half of them are dead, right? So it takes somebody to think about it. But it's interesting to me. The American Rivers did a study 2 years ago, 3 years ago now, that showed that green infrastructure, when properly deployed, created more jobs for the longest period of time for the least amount of money. So this is good stuff, isn't it? I mean, it's great stuff. So now the other part of this is, where do we use these tools? Because too many times I see novelty rain gardens go in. And that's not a bad thing. It's good to get the public educated. It takes the public to work together. But what I see is they're deployed in problem areas. Our conventional approach to stormwater is, where the problem occurs is install the fix. It makes sense. We've got flooding over here. Let's dig a hole. Like Melanie said, we're downtown. We've got this problem. The closest pipe is a sewer pipe. So we run rainwater into the sewer system. And now we're building pipes 5 times larger than we need to handle the rainwater. And then we have to treat it and all the energy. So a watershed approach says, let's take a look at our entire watershed and the basins. So this is Crow Creek Watershed. This is what the students are doing. And this is what we're getting from James. He's going to do the whole approach and look at it. And what we get out of this when we're done is we look at the different water basins. Now this is a 50-year-old condominium complex. They wanted to get their stormwater fixed because they were seeing not only bank erosions, they were starting to see some of their condominiums fall into the stream beds that they had. It's expensive to fix. And they put in a $450,000 gabion wall, and all it did was move their problem. They call it armoring the stream banks. All it did was move that problem farther downstream. With the green approach, they're hopeful that they'll be able to avoid spending that much money and having that type of a result. So we look at what flows we have. This is a 1-inch rainfall. We look at the property that happens, and here's my point. This red line is their property. And where is most of the rain coming from? Their neighbors. And you're going to see the same thing right here in Crow Creek. The majority of the water that's coming through Crow Creek is coming in from our agricultural lands up north. And then we've got the city itself that generates an awful lot because of the impermeable surface areas. So what we're doing here is we prioritize the areas, and you'll notice the priorities seem to go around the outside, and our experience has been the farther upstream we go, the less expensive the solution is and the more effective it is. And ideally, in a long-term goal, is that every piece of property here does not have any stormwater runoff. Our goal eventually is zero stormwater runoff. If we achieve that, you will start to see all of this become dynamic. And it works, and it's sustainable. So we take this street here. I graduated University of Arizona. This is Speedway Avenue in Arizona. Anybody been there? Yeah. It was the ugliest street in America, 1968, Life magazine. I'm dating myself a little bit. This is the ugliest street in America. And we can start to look at it a little bit differently. It takes a different approach, but it's absolutely possible. So, to leave you, think about green infrastructure. Number one, it's natural. It mimics nature. Number two, it's more complete. It gives us filtration that we don't get today with conventional approaches. It's lean. Many times it's less expensive, especially when we combine our existing gray infrastructure, which does a great job on flooding and the 100-year storm events, but it does a miserable job on the 1-inch storm events, which is really where our problem is today. And this is an evolutionary approach, and it's the future. It's where things are going into the future. So with that, I just want to leave you with one thought, and this applies to global warming as well as to stormwater mitigation. In nature, there's no good, there's no evil, there's only consequences. Thank you very much.